We have question 10. It's out of 4 marks. It's the last question in this series. But we first of all have to find the resultant vector a plus b for 1 mark. We're given vectors a and b. Pause the video if you want to have a go at this, but I will continue. So we have the vectors A is 2, 5. And B is 3 and 2p minus 10. We want to add these, so let's do A plus B. We then get 2, 5 written vertically plus 3, 2p minus 10. A few things to note is we underline vectors. Normally in an exam, they will either underline or print them in bold, but we are going to underline to make sure that we know that A and B are vectors. And the vector is we have an x component and a y component. So this is the x component and this is the y component. For a two-dimensional vector, the idea is you go 2 along and 5 up. That would be, do this in green. So if you start at the origin or any point and you go 2 along and 5 up, you would go 2 along, 5 up. That would be the point 2, 5. You don't have to start at the origin, but it makes this example much easier. And we put an arrow. But that's an aside to the rest of the question, so I'm going to rub this out. We want to add our x components. So 2 is the x component in the vector A, and 3 is the x component in B. So 2 plus 3 equals 5. Let's look at the y component. Well, 5 is the y component in A, and in vector B, the y component is 2p minus 10. So we get 5 plus 2p minus 10. We can simplify this. 5 is the new x component, and 5 minus 10 is minus 5 plus 2p, giving us 2p minus 5. And in my judgment, this would be the first mark out of 4. It might differ depending on the year, depending on how difficult the rest of the exam was, but my personal judgment would be this would be the first mark. Let's look at B, 3 marks. The magnitude of B plus A is denoted m. We have to show that m squared can be given as the expression shown. Now, we have found a plus b. and we know that b plus a is the exact same. So we can say that a plus b equals b plus a. And again, we have 5 and 2p minus 5. And we know if we have a 2D vector, suppose we have the 2D vector x, y, its magnitude will be given by x squared plus y squared. Let's logically think about why that is. Well, as I said in the last part, you're going x along and y up, and this is the vector xy. Now, if you make a triangle, and you know that this is x, because it goes x along and it goes up by y, excuse me, then you want to find the magnitude, and we mean by magnitude the length of the vector, which in this case would be the hypotenuse if you made it into a triangle. And we use Pythagoras. So I'm going sorry, my throat goes funny a lot. So we can use this to help us. So we denote sorry, the magnitude as m, but we can also write it as b plus a. We can make x, the x component is 5, so 5 squared plus 2p sorry, 2p minus 5 all squared. Make sure you square the entire thing. I do apologise again about my throat, but it's kind of a common theme in a lot of these videos. And in my judgment, this would be the second mark. The question asks us to show m squared. So if you want to find m squared, we're going to square the m, obviously. So we've squared the left hand side, but if we want to square the right hand side, then the inverse of the square root is a square. So if you take a number and you square root it, then you get the number back again. So if we want to square this, then the square root must be over the entire of this expression in blue, which it is. So if we square both sides, the square root and the square cancel each other out, and we're left with the expression. And let's expand it out. So 5 squared is 25. and plus 2p minus 5 multiplied by 2p minus 5. The method I teach for expanding 2p minus 5, 2p minus 5 would be a table. And if you've not watched my last videos, then I'll show you this. So 2p, now 2p minus 5 means 2p plus minus 5. So let's do 2p and minus 5. These two adding to make 2p minus 5. Again, and 2p minus 5. Two p multiplied by 2p is 4p squared. 2p times minus 5 is minus 10p. Then minus 10p again. Minus 5 multiplied by minus 5 gives us 25. Collecting like terms, we get the only term in p squared is 4p squared, but we have a minus 10p and a minus 10p, so adding them gives you minus 20p. And the only term independent of p, i.e. it doesn't have a p at the end, in layman's terms, is the 25. So m squared equals 25 plus, and let's add on what we have here, so that's 4p squared minus 20p plus 25. We want to simplify. The only term in p squared is 4p squared minus 20p. We've got two terms independent of p. 25 and 25 gives us 50. And that's us finished. Let's make sure that we got the correct expression, and we did. So the last 2 marks combined I would give for this, in my judgment. So we've done 10 questions, and you now see that there's some questions in an exam that are really easy, and maybe easy is the wrong word, routine is the better word, and it might ask you to add 2 fractions, it might ask you to simplify a surd, like simplify, I don't know, root 45. It might ask you to find the mean of numbers. Those types of questions you can learn how to do. You can practice and you can go in that exam knowing what you're doing. But some questions take a lot of thinking time. And the questions I've done in this series come under the category of the types of questions that you have to spend sometimes a substantial amount of time thinking about. Now, just because you got these questions wrong, or you found them hard, or you didn't get many marks, does not make you bad at maths. Many pupils, even that would get an A, would find these questions hard. So I hope you found it useful, and yeah, best of luck with the studying. Thank you for watching.